This is Dr. K. Abdul Basith. I am working as a professor in CSE department, Marri Laxman Reddy Institute of Technology and Management. Today we will discuss about the concept of pointers. Pointer is a derived data type. So if you consider the concept of data types, the data types are classified into 4 types: primary data types, derived data types, user defined data types, and fourth one is empty set, that is void data type. So derived data types are derived from primary data types, and primary data types plus some kind of type operators, we are defining a new type. So if primary data types plus the type operator parenthesis, you are deriving a new type called functions. Same thing, primary data types plus type operator subscript, you are defining a new type called arrays. And primary data types plus type operator asterisk, you are defining a new type called pointers. So pointer is a derived data type. So if you consider a variable, whenever you declare the variable, some characteristics of the variable maintained by the compiler. This is called compile time descriptor. So it is identified by 6 tuples. Among that, the one of the tuple is address. So the address is also stored in a variable. So that variable which stores the address of another variable is called as a pointer. So pointer is a variable which stores address of another variable. So here in this figure, this number is called as a variable which is having a value of 26, it is called as a value, and the 1100 is called as address. Assume a num having a address as 1100. So now you consider PTR is called as a pointer. Pointer stores the address of a variable, means the 1100 is the value stored inside the pointer, and the pointer itself also having address. So you can access the value of the num variable through pointer. So this is called indirect accessing. So a pointer is a constant or a variable contains an address that can be used to access data. Pointers are special variables that can hold the address of another variable, pointer name and a location, both of which are constant. So a pointer is a variable that stores a memory address. So whenever you take the memory is divided into number of locations, each and every location identified by some address. Okay, so the address here, instead of handling a direct value, it holds the address where the value is stored in the memory. There are 2 important operators we are using in the pointers concept. Those are, one is asterisk, it is called as a dereferencing operator or indirection operator, and second one is address of operator, that is ampersand. So the asterisk used as a declaration for the pointer, and it also used as a value at address operator. And coming to the ampersand is used as a address of operator. So we can easily access the address by using ampersand symbol. These are the 2 operators used in the pointers concept. So coming to the pointer declaration, a pointer is declared as, the syntax of pointer is pointer types asterisk pointer name. Here this pointer type is called as a primary data type, valid primary data type. It may be integer, float, character, double, long double, any primary type. So the star is called as a type operator. star it called as a typo operator, and the pointer name which is a valid identifier, which is valid identifier. So if you consider a declaration of a variable, we are having type as well as identifier. This is declaration of a variable, and if you consider declaration of pointer, so typo operator is also included, same identifier. So this is declaration of pointer. So we can declare in different ways the pointer. So you can declare, if you want to declare the pointer, you can declare like this, int star p, like this. You can also declare the pointer like this, int star p. It also declare like this, int star p. Three all are valid. So in most of the books it is referred this type of declaration. So all are valid. Now so if you consider examples for the pointers, so char a, you are declaring a character variable, int n, you are declaring a n as an integer variable and x as a floating point variable. Now coming to the pointers, so char star p, so p is a pointer which stores the address of character variable, and q is the pointer which stores the address of integer variable, and r is a pointer which stores the address of floating point variable. So this is all about the pointers, and this is the variables. So extra thing, we are using this type of operator. This type of operator used for defining the or declaring the pointers. Example, you can consider a program. Here I am using a number and assigning a value, initializing a value with 0. So number is a variable, normal variable, integer variable, and I am using a pointer called int star pointer. So pointer is a integer pointer, and we are initializing with null value. Null is also a pointer, and here number I am assigning with 10. So I am printing ampersand number. Ampersand number means, for example, whenever you are declaring a number, so memory allocated for the number, assume the address of the number is 1000 and you storing 10 inside this number. And if you consider a pointer, pointer is also a variable which is also having address. Assume the address of the pointer is 2000, and here, so what happens here, you are storing null inside this pointer. You are storing null inside this pointer, and here what you are doing, you are printing a number. So address of number, it will print here 1000. This is called address, and value of number, that is number is nothing but it will print 10. So in this step, what you are doing, you are assigning a address of number to a pointer. Address of number to a pointer means, what is the address of number? 1000. 1000 is replacing with null. Now currently the pointer is having 1000. Means a logical link is created between these two. So pointers address of pointer, it will print 2000, and the pointer actually having address of number, that is 1000, and here you are using value of pointer. So pointer having what? 1000. So value of 1000 is nothing but, again indirectly you are accessing value of number only, 10. So this is the how the pointer is used in the programming. So now pointer initialization. So like variable initialization, we can also initialize pointers. So for example, if you have a variable int a, this is called declaration of a variable. Next, you can also assign a value for a variable, a is equal to 30. So this is called declaration of a variable, and this is called assignment of a variable. So if you do, whenever you are declaring, you are assigning a value, initial value, then it is called initialization. This is initialization of a variable. So like that, variable declaration, variable assignment, variable initialization, we are also having pointer declaration. So declaration of pointer is int star p. So assigning value for the pointer is ampersand a, and initialization means you can lightly, while you are declaring, you can in star p is equal to ampersand a. So you are doing same thing, means for example x is you are declaring as 10, and here you are initializing the pointer with ptr is equal to ampersand x. While you are declaring, you are assigning a value, initial value, then it is called as a initialization. So like a variable initialization, we can also initialize pointer. So we can't initialize pointer like this. For example, you are declaring in a int star p is equal to ampersand x, and you are declaring x after the initialization. So this is invalid. So x must declare before this pointer initialization. So make it note for this. And one of the most common causes of errors in programming, uninitialized pointers. So pointer must be initialized. If you don't know, if you are not assigning any address, at least the pointer assigned with null pointer. Okay, and we can't assign a direct constant for the pointer. Int star p is equal to 1000. So this is invalid. You can't assign because 1000 is a memory address. So whether 1000 is available in the memory or not, we don't know. That's why you can't assign a constant directly to the pointer. Hope you understand. These errors are difficult to debug because the effect of error is not found until the program execution. So here you can see this in a diagrammatic representation. So int star p is called as a declaration, and p is equal to ampersand a as a assignment. Both these two are done using a single statement. So int star p is equal to ampersand a, it is called as a initialization. So that is all about pointer initialization. So accessing variable through pointers. So here dereferencing operator or indirection operator is used to access variable through pointer. Indirection operator is unary operator. It is a unary operator. So asterisk you are using as a unary operator means followed with a single ampersand or single operand. So then it is called as a pointer. Then it is called as a pointer. Same asterisk you are using with the binary operands, two operands. So this is acts as a multiplication operand. So now the result of above expression that can be used to access the pointer variable for the purpose of inspection. So to access the variable a through the pointer p, p is declared as star p and p is initialized as p is equal to ampersand a. So we can also declare and initialize the pointer in a single step. This is called pointer definition or pointer initialization. Recommended that pointer should always initialize to some value before starting using it, otherwise it may lead to number of errors. So example you can consider what I am doing. So I am declaring a variable called my variable. So assigning some memory. Assume the memory address is of this variable is 5000. So the value I am initializing is 1001. So now I am declaring a pointer that is called ptr. Assume the address of ptr is 6000. So what I am doing, ptr is equal to ampersand my variable. So address of this my variable is 5000 stored in ptr, means there is a logical link created in between these two. So what I am doing, I am printing address of my variable. So address of my variable is 5000. It will print 5000 here, and value at address ptr. So value at address ptr. So ptr consisting what? Ptr consisting 5000. So value of 5000, that is again 1001. The answer for this is this one. So the asterisk you can use in two ways. One is for declaration of pointer. Another way is for use as a value at address operator. Value at address operator. You can use in two ways. While you are using asterisk with a data type, that is called pointer declaration, same asterisk you are using with a variable, so then it is nothing but a value at address operator. Hope you understand. So now another example you can consider how the pointers used in a programming. So if I am writing a program for two integers, addition of two integers using pointers, what I am doing, I am taking first, second as a variables. Assume this is the first variable which is having address as 1000, and I am also using second variable which is also having address called 2000. I am using a pointer. Pointer is a p is a pointer which is having address 3000, and q is also a pointer which is having a address called, so address assume 4000. So pq are pointers, and first and second are variables, and we are also having another variable called sum. Assume the sum address is 5000. So what happens here? I am entering two values using scanf statement. Ampersand first, ampersand second means I am reading 10 in a first and 35 in a second argument, that is second. So what happens? Next time what I am doing, assigning the address of integer variable p to the pointer first, and assign the address of integer variable q in the pointer second. So what happens here? So address of first is stored in p, that is address of first is 1000. So address of second is stored in q, that is 2000 here. So what I am doing, I am performing sum operation. Sum is equal to star p plus star q. So star p is nothing but, so this is written like this, star p is nothing but value at address p plus value at address q. So what actually the value of p? What is p here? Value at address p is 1000 plus value at address q is 2000. So value of 1000, that is nothing but 10. Value of 2000, that is nothing but 35. So totally the sum is 45. 45 is stored in sum variable. So you are printing sum means it will print 45 as a result. Like this the pointer will work. So you can indirectly access the variable values using pointer. Not only variable values, the concept which is stored inside the memory, anything, you can take variables or pointers, structures, functions, anything they occupying the memory. So the memory having some address. If you know the address, you can access the content of the memory using pointers. So C is rich in pointers. So here, so anything, if pointers, we can use the pointers for two purposes basically. One is called dereferencing, that is called indirect access. Indirect access. Another one is for dynamic memory management. So memory can be allocated in two ways. One is called static memory allocation. Another one is called dynamic memory allocation. So static memory allocation, memory allocated during compilation time. In dynamic memory allocation, memory allocated during runtime or execution time. So for this memory allocated from heap area. So the heap area not having names because they uses nameless variables. These nameless variables only access through address, that is with pointers. So having advantages, pointers also having some disadvantages. So the disadvantage of pointer is, one is dangling pointer problem and memory leakage problem. Memory leakage problem. So what is a dangling pointer? Dangling pointer is nothing but you are declaring a pointer into star p comma star q, and here you are also declaring some int x. So what happens here? So you are allocating a memory p is equal to ampersand x and q assigned with x or q assigned with p, and because of something, so you free using a free function, you are deallocating a memory of occupied by the p, but q is pointing to the same memory. So now q becomes dangling pointer. So while you are using explicit deallocation function, by using those functions you are deallocating a memory which is allocated. So during the program execution, so other pointers are pointing to the same memory or not, we should clarify before that deallocating the memory. Otherwise dangling pointers will be created. And if you dynamically allocate the memory, so memory allocated for that address is stored in a pointer p is equal to something 1000 by allocating a memory using malloc or kelloc. So what happens here, this can access only through this pointer. So same pointer variable is allocated for another memory also. So the 1000 is replaced with the 2000, but the 1000 memory is not at all useful, not at all accessible. So then it is called as a memory leakage problem. So there are advantage of pointers as well as disadvantage of pointers. Advantage of pointer is indirect access, and second one is a dynamic memory management. And the disadvantage of pointer is, one is there is a possibility of creating dangling pointers because of using explicit deallocation function called free. And coming to the another disadvantage is memory leakage problem. So using dynamic memory allocation, you are assigning a pointer, so same pointer is allowed for another memory allocation. So the previous memory which was allocated, that will not be accessed, because the pointer which is used for the accessing, that is assigned with another address. So the first memory is not useful, means you can't claim that memory, you cannot access the contents of that memory. So because the pointer is updated, so this is called memory leakage problem. So these are the pointer problems. So now pointers to pointers. So we can also create a pointer can access the address of a variable, because you can store the address of a variable in a pointer. Through pointer you can access the variable. So we can also create a pointer to pointer. Means, see here, what I am doing, I am declaring int a, that is declaration of a variable, int star p, that is nothing but a declaration of integer pointer, and the star star q, so it is nothing but pointer to pointer. So if you declare a, memory is created, assume the memory is 1000. Okay, so if you assign a is equal to 10, 10 is stored here, and you are also creating int star p, means p is a pointer which is also having address 2000, and you can also create a pointer to pointer q, that is also having address called 3000. So what happens here, so a is equal to 58 you are using, so means 58 is stored in a. So ap is equal to ampersand a. So what is the address of a? 1000. 1000 is stored in here. So this is creating like this, pointer to variable. Now pointer to pointer is created here. Q is equal to ampersand p. What is the pointer address? P address is 2000. 2000 is stored in q. 2000 is stored in q. So it is accessing this. So the q is a pointer to pointer. Pointer to pointer. So what happens here, if you print a will print 58, and star p, value at address p. So value at address p. So value of what you call 1000, value of 1000 is nothing but 58. So it will also print 58. Now star star q, star q means star q means what? Value of q. What is q? Q consisting 2000. So now value of 2000, value of 2000 is 1000. So now value of 1000 is again 58. So this is direct, this is indirect, this is pointer to pointer. Value can access through indirection with indirection. So same value you can access in three ways here. So this is the concept of pointer to pointer. So the example demonstrates two level of redirection. Many applications may require two or more levels of redirection. Each level of redirection requires separate indirection operator. Separate star is required for each indirection. So same concept you can consider. So what I am doing, I am declaring a variable called value, character variable, and I am storing a character, that is C, which is having some address, that is called 8000 is address of variable value, and here I am declaring a pointer p2. So p2 I am storing, so it is a value, char value I am using, char value is equal to C I am storing. So now what I am doing, pointer p2 is equal to ampersand of value I am storing. So 8000 is stored in p2. Now what I am doing, I am declaring int star p2. I am declaring int star p1 is equal to ampersand of p2. What is ampersand of p2? That is 5000. 5000 is stored in p1. So because of this, so you can store 5000 inside this. The 1001 is the address of pointer to pointer. So here pointer p1 declared as a star p1, pointer to pointer is declared as a p2. So that is another example for pointer to pointer. If we go for example program, so what I am doing, I am declaring x. X is a variable. Assume the address of x is 1000. I am storing a value 10 here. So I am declaring a pointer. Assume the address of pointer is 2000. I am declaring a pointer to pointer, that is q, that is address is 3000. What I am doing here, after this, p is equal to ampersand x. What is the address of x? That is 1000. 1000 is stored in p. Means you are creating a logical link like this. What happens here? Q is equal to star p, q is equal to ampersand p. So address of p, address of a pointer stored in pointer to pointer. So it is logical link created like this. What I am doing, so I am printing x value ampersand x. What is the x value? X value is 10. Ampersand of x, that is 1000. The output of this is like this. And coming to the second one, here I am printing with star p and p. Star p means value at address 1000. Value at address 1000 is again 10. What is the actual value? The p consisting 1000 only. So answer is same. Now pointer to pointer you can take. So value of q. Value of q. So what is q? Q is nothing but 2000. So value of 2000. Value of 2000 is nothing but 2000 consisting 1000. So again value of 1000. Value of 1000 is nothing but 10. Means the answer is 10 here. And value of q. Value of q is nothing but value of q. Nothing but it gives 1000. So same answer will come. One is direct, indirect. Third one is pointer to pointer. Hope you understand this. So now pointers, we can have a type associated with them such as a character and float etc. So we have some three types of compatibility we have. So each pointer takes attributes of the type which it refers to in addition to its own attributes. So there are three compatibility types in the pointers: size compatibility, dereference type compatibility, level compatibility. Size, type, level compatibility. These three compatibilities are there in pointers. While we are discussing pointers, we need to concentrate on these three. So coming to the size compatibility, the size of all pointers is the same. So for example, if you give int a, float b, char c, okay, so integer occupies in a Linux machine, it is 4 bytes. So float occupies 4 bytes, character occupies 1 byte. But if you consider int star p, int star float star q, or char star x, all the pointers occupy, if they are near pointers in Linux platform, 64-bit platform or in 16-bit platform, they occupies 4 bytes. So in a 32-bit platform, they occupies 8 bytes. Means the size of the pointer will not depends on the type of the pointer. Size of the pointer, it is decided, all the types of the pointers have the same size. Size is depends on whether the pointer is near pointer or far pointer. In case of near pointer, we are the pointer having in the same segment. So if the pointer storing or pointing to the other segment variable, so it occupies segment address as well as offset, that is far pointer. For storing far pointer, we require extra memory. So we'll discuss, see this. One other hand, the size of the variable that pointer refers can be different. The pointer also takes attributes of the type being reference. So here the pointers are near pointers and far pointers. A near pointer stores 16-bit addresses, which means it can only access memory within the current data on a 16-bit machine. So which can access 64 KB of data using near pointer. So within the segment, we don't need to use extra memory for storing the segment value because they all are near pointers. They are memory allocated in the same segment. So they are called as near pointers. So if you consider example for this, so what I am doing, I am declaring a in the same segment, I am storing a memory 1000. So a having 10 value and P is a pointer which is also having same address. So no need to store the segment address. So they are in the same address, same segment space, segment space. So I am using a character, so that is X stored here. So the address of this is 3000, and I am using a Q is a pointer, so which is address is 4000. So now I am also using a float variable. So the float variable storing address as 5000, and I am using a R as a floating point pointer, that is also in the same segment, that is 6000. They all are near pointers. The pointer P, Q, R all are in the same segment, so they are called as a near pointers. So here they no need to store the segment address. They only store the offset value only they can store. The offset value is 2000, the offset value here is 4000, the offset value here is 6000. See this, what happens, size of A. So size of a variable, A is a which type of variable? Integer variable. On a Linux platform, A occupies 4 bytes, and character occupies size of character. So size of character is 1 byte, and size of floating point, that is 4 bytes. And the values which are stored inside this, so you can access the values using indirection operator. Value of P means what? So here in this, what you are doing, P is equal to address of A, 1000 is stored here, and Q is equal to address of B, so 3000 is stored here, and C is equal to R is equal to address of C, so that is 5000 here. So what happens here? So you are creating indirection like this. So here it is pointing to this. So what you are doing? So here the C storing the value 34.5. Okay. So now what you are doing? So now you are printing size of P, size of Q, size of R. All are pointers only. All pointers are in the same segment. So that's why if you are using a 16-bit machine, the near pointer occupies 4 bytes. If you are using a 32-bit machine, so near a pointer occupies 8 bytes. Hope you understand. So here this is a 32-bit. This is a result of 32-bit machine. So you can occupies 8 bytes for near pointer, and far pointer. So 16-bit machine far pointer occupies 8 bytes. So another 32-bit machine, it occupies 16 bytes. So hope you understand. So dereference type compatibility. The dereference type is the type of the variable that the pointer is referencing. It is invalid to assign a pointer of one type to a pointer of another type. So means if you are declaring a pointer int A, you are declaring, and you are declaring float star P, and you are assigning P is equal to ampersand A, which is invalid. Why? P is a pointer of floating point type, means it can points to address of only a floating point variable. But here in this case, you are storing a floating point pointer is assigned with a integer variable address. So that's why, so it is not accepted. So a pointer to a character is only compatible with a pointer to a character. A pointer to integer is only compatible with pointer to integer. Do not assign pointer to a character, pointer to integer. So the exception is that if you are using a generic pointer like white star is called as a generic pointer. So you can assign any type of variable for the generic pointer. So this is called type compatibility. So coming to the casting of a pointer, so if any type compatibility problem is occur, so we can also perform type casting using cast operator. Here in previous case, so it is actually PC is a pointer for character and A is an integer variable. So integer variable address is converted into character pointer, then it assigned to character pointer, it is valid one. So this is called casting of pointers. You can do before assigning to the other pointers, you can cast. So you can consider a program demonstrating a casting of pointers. See here, star p is integer pointer, star q is a character pointer. What you are doing here? So a is assigning address to the integer pointer. They are valid one. They are valid one. But here, if you are assigning like this, p is equal to ampersand b, q is equal to ampersand a, they are error, because p is a integer pointer but points to address of character variable, and q is a character pointer points to address of integer variable, which gives error. So this error can be modified or error can be eliminated by writing the same statement using cast operator. So before conversion you put int star, before conversion of ampersand a you put in char star, the problem will be solved. They are valid. So this is the use of cast operator using pointers. So now third one is level compatibility. A pointer to int is not compatible with a pointer to int. So the level is different. So for example, if you use a, so a address can be stored in a pointer and pointer address can be stored in a pointer to pointer. So if you are not using this, you are not following, so simply you are using PPA is equal to address of a. So level compatibility problem will occur. So example, you can consider a is integer, so b is also integer, so integer pointer, so pointer to pointer. So here a address of integer variable assigned to a pointer, it is accepted, and here also address of p is assigned to a pointer to pointer, so pointer address can store in pointer to pointer, it is also valid, and here star star p, a pointer to value can be stored in a b. B is a variable, normal variable, it is also valid. But here what you are doing, so star a you are taking, star a is value of a you are storing in pa. Pa is a pointer can store address, not a value. So this is invalid. So now ppa is equal to pa. So pointer to pointer can store address of a pointer, not value of a pointer, it is also invalid. So now b is equal to value of ppa. Value of ppa is the address. So address can't store in a variable. So that's why it is also invalid. So this is called level compatibility in pointers. So you can use pointers with arrays also. So arrays and pointers, you can consider array name can be used as a pointer variable because name of the array stores base address. Name of the array stores base address. So assume this address is 1000, this address is 1002, this address is 1004, 1008, 1010. So here why I am taking 2 bytes means, so if it is implemented in 16-bit machine, so integer occupies 2 bytes. So array is a group of elements or elements of same type. So continuous memory is allocated for the array. So this 1000 is called as a base address and name of the array consisting this base address. So that's why the array name is can be used as a pointer variable. The base address array is assigned to a pointer variable. Base address of an array specify address of first element means a is similar to address of a of 0. Both are same. Both are same. By using pointer arithmetic, other address elements of the array can be accessed. So here pointer increments with the scale factor. So scale factor for integer is, if it is 16-bit machine, 2 bytes. Scale factor for float is 4 bytes. Scale factor for character is 1 byte. So if you increment the pointer increments with the scale factor. Hope you understand. So now you can consider example. So you are declaring a int star ptr is a pointer and you are declaring a array of a of 4. So a of 4, this is called a of 0, a of 1, a of 2, a of 3. You did partial initialization. So 1, 3, 4 and fourth one you are not initialized. So default the compiler assigns 0 here. Compiler assigns 0 here. So this is implemented in 16-bit machine. That's why integer occupies 2 bytes. So assume the a of 0 address is 1290 and a of 1 address is 1292. So a of address of a of 2 is 1294. Address of a of 3 is 1296. This is address. These are the values. These are the array elements. Okay, so what is the starting address? 1290. 1290 is a base address, and the name of the array which stores base address, you can assign this using ptr is equal to a, or you can also assign ptr is equal to ampersand a of 0. These both statements are valid statements. You can assign like this or like this. So this is array and pointers. So pointer arithmetic, pointer incremented, I already told, increments with the scale factor. So if you are using an integer array, so the increments with the scale factor. For example, you can assign, you can take this address of this is 1000, this is 1002, this is 1004, 1006, 1008. Assume like this. So what happens here? What I am doing? So I am assigning p is equal to ampersand a of 1. Ampersand a of 1. According to this, so p value is 1002. So what happens? I perform p plus 1. P plus 1 means, what is p value? 1002. 1002 plus 1, and it increments with the scale factor. What is the scale factor for integer on a 16-bit machine? It is 2. So this is 1002 plus 2 means 1004. If p plus 1 you did, it points to 1004. So same thing, if you perform p plus 3. P plus 3 means what? P is nothing but, what is the value of p? P is the value of 1002. 1002 plus 3 into scale factor. What is the scale factor for integer in a 16-bit machine? 2. 3 2 just 6. So now 1002 plus 6, that is 1008. So p plus 3, if you increment the pointer by 3, so it points to 1008 location, that is 22. Hope you understand. So pointer increments with the scale factor. So you can access the value of array using pointer or using normal index. You can access both. So you can access a plus 1. So a plus 1 you can points to 4 only, or you can also points to p. Directly you can use like this. So hope you understand. So another concept we have array of pointers. So array of pointers is another useful structure for arrays and pointers. The structure especially helpful when the number of elements of the arrays are varies. So you can consider this example. For example, 2-dimensional array you can consider. So here these memory locations are wasted here. These memory locations are wasted here, and here in third row. So this is row 1, row 0, row 1, row 2, row 3, row 4. And here this is column 1, column 0, column 1, column 2, column 3, column 4, column 5, column 6. So array subscript starts with 0. Array subscript starts with the 0. It's a 2-dimensional integer array. So in this we have rows and columns. So here we are having 5 rows and we are having 7 columns. So you are storing some data. So a of something 0 0, that is nothing but this location. So 0 1, nothing but this location, and 2 of 0. 2 of 0 means 0 1 2. 2 of 0 means this one. This 22 is pointing to 2 of 0. So like that you are assigning some values in the table. What happens here? So these locations you are wasting the memory. So such type of arrays are called ragged arrays. The arrays which has uneven, so right border is called ragged arrays. All the elements are not full. It leads to wastage of memory in 2-dimensional array. So use of array of pointers can solve this problem. So create 1-dimensional array with 5 elements and then join them through a array of pointers. How it is eliminated, you can see this. So to declare array of pointers, we are using this syntax, type star name. So array index of the pointers. So here you can see char star table of 6. So each table of 0, table of 1, table of 2, store the addresses. Store the addresses. Same thing you can use like this, pointer to pointer. Pointer to pointer you can see, because pointer to pointer can only point the address of pointer. So here what you are doing, you are assigning a address in the array. You are storing the address of a pointer in a array. So you can see example. Assume So assume this is 1000, 1002, 1004, 1006. So address of this 13, that is nothing but you can store here, assume 2000, 2001, 2002, 2002, 2004, 2006, 2008, 2010, 2012. So now this one is address is 3000, assume, and here this is 4000, 4002, 4006, and here 5000, 5002. Assume these are the addresses of these arrays, and these addresses you are storing in a pointer to pointer table as a array of pointers. So 1000 stored here, and 2000 stored here, 3000 stored here, 4000 stored here, 5000 stored here. So each element of the table is pointing to another array starting address, another array starting address. This concept is called array of pointers, array of pointers. So the problem of ragged arrays can be avoided here using the concept of array of pointers. Here this is allocating a memory dynamically using a calloc function. Okay, so we are allocating a memory for array of pointers. They return pointer to pointer, pointer to pointer. So example, you can consider what I am doing. So I am taking array of x, that is 5 values, array of y, array of z, and I am declaring pointer to pointer. So here I am declaring array of pointers, array of pointers. I am storing the address of a of 0 is x, x, y, z. So this is array of 0, array of 1, array of 2. So I am storing the starting address of x, assume 1000 is storing here, and y, assume starting address is 2000, assume z address is 3000. So this is you can access, and using this code I am printing each element of the array. So using array of pointers concept. Hope you understand this. So another pointer we are going to discuss here, that is generic pointer. Generic pointer is also called as white star. So white star called as a generic pointer. So pointer to white generic pointer that can be used to represent any data type. Normally, so a integer pointer can assign the address of integer variable. You can't assign a character address into a integer variable. If you want to assign, you need to cast it. But in case of generic pointer, for the generic pointer, if you declare white star ptr and you declare int p or int a float b, so this p can assign with ampersand of a, p can assign with ampersand of b. Both are valid. Both are valid because ptr is not a normal pointer. It is a generic pointer. It is pointing to generic pointer data type void. A pointer void can be assigned with any type without casting. Okay, so example you can consider here, white star ptr you are declaring as a generic pointer. X is an integer variable, y is a floating point variable. Sometimes you can assign ampersand x to ptr, sometimes you can assign ampersand y to ptr. Both are valid because ptr is a generic pointer. So normally integer pointer can points integer variable address, floating point pointer can points floating point address, but generic pointer can point any type of address. Hope you understand. So this is all about a pointer. So in this class we are discussed about what is pointer, what is the use of pointers, what is the problem with pointer, how to declare the pointer, how to initialize the pointer, how to access the pointer, okay, and what is the compatibility rules in the pointers, and also discuss with the array of pointers, pointer to array, and we can also discuss about generic pointer. So for this I used references from Concept of Programming Language by Robert W. Sebesta and Computing Fundamentals and C Programming second edition by E. Balaguruswamy, and I also follow some websites like greeksforgreeks.org. I used this as C pointers concept here, so as a references for my topic. Thank you, Tom.